Okay, let's jump right into this explainer. We're unpacking an absolutely critical business case today: industrial fire monitoring technologies. If you're an executive or facility manager trying to allocate budget to protect your assets, you know that keeping your bottom line safe means keeping your operations running. Today, we're breaking down the vital differences between flame detectors and thermal cameras to help you build a smarter, much more resilient facility.
Here is our roadmap for today. We'll be looking at reaction versus prevention, understanding flame detectors, understanding thermal cameras, comparing pros and costs, and finally, the strategic case for using both.
All right, part one, reaction versus prevention, managing operational risk. To start, we need to completely reframe how we look at facility safety and hazard management. So ask yourself this: are you paying to detect fires, or are you paying to prevent them? If you're running a high-risk industrial facility, how you answer that question fundamentally changes the technology you choose to deploy.
And honestly, this right here is the fundamental divide. People lump these tools together a lot because, hey, they both use infrared energy to reduce risk, but they are absolutely not the same. Flame detectors allow you to react quickly after ignition has occurred. They literally need to see an active flame. Thermal cameras, on the other hand, are all about prevention. They help you find the heat buildup that causes the ignition in the first place.
Moving right along to Section 2, Understanding Flame Detectors, the Speed of Safety. Let's look at the exact mechanics of these devices.
So, how do flame detectors actually work? Well, they're looking for very specific radiation patterns that scream combustion, and they use a few distinct sensor strategies to do it. You've got UV detectors scanning for ultraviolet radiation, IR detectors tracking infrared energy, and then these super smart combos like UV/IR or multispectrum IR3. Those actually compare multiple bands of light to filter out false alarms, like a welder's torch or a weird glare from the sun. That's exactly why they're the go-to for high-risk zones like tank farms or turbines where a fire can escalate in a flash.
Now, if you look at the spec sheets for these things, they speak a very specific language: code-required safety. You're going to see heavy-duty acronyms like SIL2 for system reliability, ATEX for explosive atmospheres, and FM3260. Basically, this is the guarantee that these devices will work flawlessly in the most explosive, hazardous environments on Earth, integrating directly into your fire panels and suppression systems.
The absolutely crucial takeaway here is speed. A flame detector is built to see fire and trigger a shutdown in mere seconds. We're talking closing valves or dumping thousands of gallons of water in the blink of an eye. But, and this is a big but, it's not going to tell you that a conveyor bearing has been slowly baking for the last 3 hours. It acts after the fire starts.
Which brings us to Section 3, Understanding Thermal Cameras, the Power of Early Warning. Let's contrast that reaction speed with condition-based monitoring.
Let's think about a hazard timeline. Days before an event, maybe you've got some friction on a slipping belt. Hours before, some material starts smoldering in a hopper. Seconds before, ignition. And boom, at 0 seconds, you have an active flame. A thermal camera steps in way early, on the left side of that timeline. It buys you hours, sometimes even days, to act, compared to the flame detector, which only wakes up on the far right.
How do they do it? By taking emitted infrared radiation and turning it into hard temperature data. These cameras are giving you condition-based monitoring of your equipment way before you ever see smoke or flames. Say a battery cell is trending just a few degrees hotter than the rest, or a loose electrical connection is sparking some resistance heat. The camera catches that anomaly instantly. Because these are preventative tools, their specs read totally differently from flame detectors. Instead of fire codes, we're talking measurement and integration language, radiometric accuracy, rugged IP ratings for harsh environments, and modern networking like Ethernet or MQTT for IoT integration. But honestly, the real magic is the analytics. You can set up custom zones and rules for hotspot detection, feeding that data directly to your operations and maintenance teams. Okay, Section 4, comparing pros and costs, the bottom line. Let's talk ROI, because the numbers matter.
When you're looking at hardware and installation costs for your planning, a certified flame detector is generally going to run you about 5 to 20 grand or more installed per point. A fixed thermal monitoring camera, usually around 7.5 to 30,000 installed. But here is the massive distinction. That flame detector covers one specific hazard point. The thermal camera can monitor an entire zone full of assets.
So, $30,000. Yes,
That is the upper end installed cost for a single, fully integrated, monitored thermal zone. It's a chunk of change up front, for sure. But think about the business case here. That capital expense is literally buying you the time to intervene before a motor goes up in flames. You're potentially preventing millions in catastrophic downtime, emergency maintenance, and asset replacement.
When we put their capabilities head-to-head, it's pretty obvious that you can't just swap one for the other and call it a day. Flame detectors give you blazing fast detection, but they warn you after the fact. Thermal cameras give you incredible early warning, but they require a direct line of sight to the surface being monitored, and they aren't automatically a direct substitute for a listed fire alarm system.
And that leads us perfectly into Section 5, the case for both. Layered protection strategy.
If your facility has high fire loads and catastrophic downtime costs, the smartest business play is establishing a layered ecosystem. Step 1. You maintain certified flame detectors for those code-required areas where you absolutely need immediate safety shutdowns. Step 2. You layer in thermal monitoring for early heat warnings on your high-value production assets. And Step 3. Tie the whole shebang together with integrated analytics. This is exactly where compliance meets operational uptime.
And seriously, don't sleep on that analytics piece. Just staring at a hot pixel on a screen isn't a prevention strategy. If a passing forklift sets off your alarms every 10 minutes, your team is just going to start ignoring the system. You need an intelligent camera layer like the AVIAN T100 system mentioned in our source materials that actively learns the normal temperature pattern of each asset. It filters out the nuisances like hot work or normal steam and actually provides trustworthy context to your maintenance teams exactly when a machine starts to drift.
This brings us right back to our core time-to-act motif for today. After ignition occurs, your response window shrinks to mere seconds. But before ignition, while you're just tracking heat, you've got minutes, hours, maybe even days to respond. Investing in both technologies gives your team the gift of time to proactively prevent a failure, alongside the ultimate immediate safety net if an explosive event does happen.
The earlier you see the signal, the more options you have. It really is that straightforward. So, as you review your own facility's budget and risk profile, I'll leave you with this thought. Are you actually giving your operations team the time and the options they need to keep things running smoothly and safely? Or are you just waiting for the alarm to ring?